In this episode of Real Chemistry, we're going to be talking about density. We're going to do two different types of calculation with density. The first is we're going to talk about how you can identify a material, what it's made out of, by using density. And the second thing we're going to do is we're going to talk about how you can calculate the mass or volume of a solution given its density. So, density is basically just a measure of how much mass there is in something per volume. And you can see that in this graduated cylinder. All those different liquids of different colors have sorted out to different heights. The least dense material floats up to the top, and the most dense material sinks down to the bottom. And it turns out that based on where they sort themselves, you can tell what material those are made out of. And that's because every single material has a characteristic density. That is to say, lead always has a certain density, regardless of when you measure it. So if you measure the mass and volume of an object and calculate its density, you can tell if it's made out of lead or not. And so that's the first type of calculation we're going to do. We're going to talk about identifying a material based on its density. So this problem reads, a chunk of metal has a mass of 750 grams and a volume of 39 milliliters. And it asks us, what is the metal? Well, I've broken down this process into 3 steps. And the very first step says, convert units to match the table. What's the table? Well, over here in the bottom left, we see a list of different materials and their densities. You'll notice that the densities are made up of the units grams per cubic centimeter. So notice there you see a measure of mass, grams, and a measure of volume, the cubic centimeters. And so what step 1's asking us to do is to make sure that the mass we're given is grams and that the volume we're given is cubic centimeters. Make sure that it matches what's on the table. The only way we can make use of this table is if we have calculated the density in terms of the same units that we know them from in our table. Okay, so we know that this chunk of metal has a mass of 750 grams. And so notice our mass already matches. The table we have has density in terms of grams per cubic centimeter, so our grams already match, no problems there. When we go to our volumes, however, we see that our volume's in milliliters. So the very first thing we need to do then is make our milliliters into cubic centimeters. Conveniently, it turns out that 1 cubic centimeter is exactly equal to 1 milliliter. So that makes this conversion really easy. Basically, even though our volume says 39 milliliters, we can just say it's also 39 cubic centimeters because 1 milliliter is equal to a cubic centimeter. So our mass then is 750 grams, and our volume is 39 cubic centimeters. And so then we're just going to plug these guys into the equation. We're going to plug 750 in for our mass, and we're going to plug 39 in for our volume. So when we take mass, 750 grams, and then we're going to divide that by our 39 cubic centimeters. And if we plug that into our calculator and compute density, that's our step 2, calculate density. When we do that, we'll get 19.23. And the units there are grams per cubic centimeter, because notice in our calculation, we divided mass in grams by volume in cubic centimeters. So now we go compare to the table, and we see that clearly there's only one of these 4 metals that match, and it's gold, which has a density of 19.32 grams per cubic centimeter. So we know that the object we were given is made out of gold. So this is how we can use density to identify a material. Because gold always has a density of 19.23 grams per cubic centimeter, we can just calculate the density of whatever object we're given, and we can know, is this gold or is it not? So that was step 3, comparing the density we calculated to the table. All right, let's do another example that's similar. This one says a chunk of metal has a mass of 3.25 kilograms and a volume of 413 cubic centimeters. So again, we're going to start with step 1, which says convert the units to match the table. And right away we see when we go to our mass, it's 3.25 kilograms. So kilograms doesn't match our unit for mass over here in the table, which should be grams. So that means the first thing we need to do is go from kilograms to grams. So our mass starts out with 3.25 kilograms. And this is another conversion that's nice to always have in the back of your mind. There's 1,000 grams in a kilogram. And so that basically means that I can multiply this by 1,000 grams and divide by 1 kilogram. That's just a conversion factor to go from kilograms to grams. And notice now our kilograms cancel out and we're just going to be left with grams. How many grams? 3,250 grams of whatever metal this is. And we know our volume is 413 cubic centimeters. That's in the right units, so we're set there. So now we can go to step 2, calculate the density. And again, we're going to plug in 3,250 for our mass, and those units are grams. And we're going to divide that by 413 cubic centimeters. If we plug that into our calculator, we'll see that we get 7.869 grams per cubic centimeter. And now, the last step, we compare that density to the table. And we go down and we see, okay, iron has a density of 7.87 grams per cubic centimeter, a pretty close match. Now, you can find tables which list the densities in a ton of different places, in your textbooks, on the internet. So it's very easy to find a table that gives you a list of all these different materials by density. So that's usually where you're going to find those. And now, since our density that we calculated is 7.869 grams per cubic centimeter, and that's a very close match to iron, we know that our material is made out of iron. All right. So that's how we can identify a material. Because every material has a characteristic density, we can actually calculate the density of an object to see, hey, what's it made out of? The other thing we use density for in chemistry is to go between the mass of a solution and the volume of a solution, or the other direction. So we're going to start by going from the volume of a solution to the mass by density. It's kind of like a conversion factor. So again, this process has been broken down into 3 steps. And step 1, again, is about the units. It says get density and volume in the same units. So the question asks, water has a density of 1 gram per milliliter. What is the mass of 1.7 liters of water? Well, step 1 is just telling us to make sure that the units we have for volume are the same across the board. And we can see here that our density is in grams per milliliter. Meanwhile, our volume we've been given is in liters. And that's a problem. We need the volume to have the same units that density has. So they both should be milliliters. So that's the first part of this problem. We can write down that our volume is 1.7 liters. And this is another conversion factor, like grams to kilograms, that you should always have in the back of your mind when doing chemistry problems. So to convert from liters to milliliters, turns out we just multiply by 1,000 because there's 1,000 milliliters in a liter. So we're going to write 1,000 milliliters. And we're going to divide that by 1 liter. And again, that's going to let our liters cancel out. And we're going to be left with 1,700 milliliters. So that's our volume. Now, step 2 says rearrange the density equation for mass. So we have to do a little algebra here because what we want to solve for is mass. And right now the equation's rearranged for density. So the way we rearrange that equation is just we multiply both sides by V. And what this does is it cancels out our V's, and it gives us a new equation. That's V times D is equal to M. So now we just compute the mass. That's the last step. And so what we're going to do is we're going to plug in our volume for V and our density for D. So our volume, remember, is 1,700 milliliters. And we're going to multiply that by our density, which is 1 gram per milliliter. And you can see here that our units cancel out. So if you ever get to this point of the problem and your units aren't canceling out, then it suggests maybe you haven't done your algebraic rearrangements correctly. So 1,700 times 1 just gives us 1,700 grams. And that's the final answer to our problem. This solution of water, that's 1.7 liters, has a mass of 1700 grams. Now, if you went around to sig figs, there's really one more step, which is if you look at the inputs for our problem, our density only has 1 sig fig. So really we can round that to 1 sig fig if you want to be precise about it. And if we round that number to sig figs, we'll get 2000 grams. So if you take into account sig figs, the answer will be 2000 grams. All right, now we're going to go the other direction. We're going to go from mass to volume. So this problem asks, acetone has a density of 0.791 grams per milliliter. What is the volume of 1.34 kilograms of acetone? And again, step 1 says get density and mass in the same units. So we always want to make sure when we're dealing with this density equation that our mass and volumes and densities use the same units of measure. And we see here that our volume is in kilograms, our mass is in kilograms, 1.34 kilograms. Meanwhile, our density has the units of grams. So the first thing we're going to want to do is take our mass, which is in kilograms, to grams. So our mass is equal to 1.34 kilograms, and we're going to multiply that by 1,000 grams over 1 kilogram. That's the same way we converted from grams to kilograms a few problems back. Notice again, our kilograms cancel out, and that's going to give us 1,340 grams for our mass. All right? And step 2 says, rearrange the density equation for volume. So this is going to take us 2 steps of algebraic rearrangement, whereas our last algebra rearrangements took only 1 step. So first thing we're going to do is we're going to multiply by v. And multiplying by v gets it out of the bottom of that fraction, which is helpful if we're trying to isolate v. So our v's cancel out, and then we're going to get v times d equals m. All right, now there's one more step if we want to get volume by itself. And that's that we want to divide each side by d. So when we divide each side by d, our d's over here cancel, and we're going to be left with the equation volume is equal to mass divided by density. So that is the density equation rearranged for volume. Now that's equal to mass over density, and so we're just going to plug in our mass and our density. So our mass is 1,340 grams, and our density is 0.791 grams per milliliter. And when we plug that into our calculator, we will get out that we have about 1694 milliliters. Again, that's really our final answer, but if we went around for sig figs, we can remember that we put in 2 numbers into that calculation, and both had only 3 sig figs. So our final answer should really only have 3 sig figs, which means we're going to round that to 1690. So that is the volume of our acetone solution. So that's how we can use density to go from the mass of a solution to the volume of a solution. So in this video, we've talked about how you can use density to identify what a material is made of, how you can use density to convert between volume and mass of a solution, and how you can use density to convert between mass and volume of a solution. So if you have any questions, please leave them down below. As always, you can subscribe to get updates about new videos. Visit my channel to see a full list of videos.